Hi, welcome to Pencil College. In today's video, we'll be moving on to more examples in Chapter 4.2 Identities. So in example 2, we are asked to find all the values, or rather to find the values of A, B, and C, given that this identity is true. So over here in this example, you realize that you're staring at a new symbol, okay, with this symbol over here with 3 lines. So this 3 lines simply means that the two polynomials are identical. Okay, so you probably want to take a note down if you're new to this. So in the first method, we'll be exploring the substitution method, and let us first pick some values to substitute into this given identity. So the first value that I probably want to pick is x equals to -2. And why is that so? Because if I were to stare at the right hand side of this identity over here, we'll realize that we have a factorized form, or rather a factorized version of x plus 2. So meaning to say, if I were to sub x equals to -2, okay, into this expression over here, -2 plus 2 gives me 0, and therefore this whole term becomes a 0, and therefore the entire portion of the right hand side of the equation or the identity becomes 0. Okay, for those who don't quite get what I mean, let me show you my full working over here. So if I were to sub x equals to -2, on the right hand side we have this, so 4 times -2, not 1, plus c times -2 plus 6. Okay, and this is equals to 2 times -2 minus 1 times -2 plus 2 times a times -2 plus b. Okay, and I was just mentioning just now that this over here becomes 0. Okay, because -2 plus 2 is 0, and therefore the entire right hand side becomes 0. Okay, and this is sort of what we want to get, because now we can safely solve for c. So over here, this is -32 minus 2c plus 6 equals to 0. Simplifying this, okay, by shifting the 2c over to the right hand side, okay, and just simplifying this a little bit further, I'll get 2c equals to -26, and therefore c is just -13. Now we have solved for one of the unknowns. We still have a and b, and to solve for a and b, we will be making use of some substitution, by selecting some easy numbers. Okay, so probably the next number I want to choose is x equals to 0. Okay, and why do I do this? Because by substituting x equals to 0, I can now get rid of the unknown a, because a times 0 will give me 0. Okay, so as you can see, the way we perform our substitution is to select values that allow us to get rid of, or rather to eliminate, some of these unknowns. Okay, so let us try substituting x equals to 0. So 4 times 0 cubed plus c times 0, okay, plus 6 equals to 2 times 0 minus 1, 0 plus 2, a times 0 plus b. Now simplifying the left hand side, we have 6. Simplifying the right hand side, we have -1 times 2 times b, and therefore -2b is 6 and b is just -3. Okay, so let me just write down what we have found so far on the top of the screen. So far we have found that c is -13 and b is -3. Also, just take note that you do not have to find the values of A, B, and C in alphabetical order. You can always find B first, or you can also always find C first. Okay, and now let us move on to look for the constant A. Okay, so now what should we substitute? Pretty much once you have found two of these constants, or rather two of these unknowns, you can substitute any value that you want, okay, to find A. So previously B was this and C was this. So let us try probably substituting x equals to 1, for example. So if I sub x equals to 1, on the left we have this. Now C we found earlier to be negative 13, so let me just sub that in as well. Okay, so sub this, and this. Okay, and this is 2 times 1 minus 1, 1 plus 2, A times 1 plus B, which is negative 3. Okay, and simplifying this, we will have on the left hand side of the equation, negative 3 equals to 2 times 1 minus 1 is just 1, 3, A minus 3. Okay, let us expand this out a little bit more. So this is 3A minus 9, and shifting the 9 over to the left, we will have this, and so A is just 2. Okay, so just to conclude, over here we have A is 2, B is negative 3, and C is negative 13. Okay, and that's all for the substitution method. Let us move on to explore the comparing coefficients method. So recall that to do this, okay, we must first expand out both sides of the equation, or usually probably only the right side. So let me rewrite the left hand side. So you realize that the x squared term is missing, so I'll just write it as 0 times x squared, so later you probably can see it clearer. And over here, this is going to be a little bit tough to expand, so I probably want to expand these two terms first. So 2x times x gives me 2x squared. 2x, sorry, let me just draw it over here. So 2x times x gives me 2x squared. Negative 1 times x gives me negative x. Use a different color to show you. So 2x times 2 gives me plus 4x, and then negative 1 times 2 gives me negative 2. Okay, let's move on to just simplify this a little bit. And this is 2x squared plus 3x minus 2 ax plus b. And what we're going to do now is to expand it even further. So let me use two colors to show you. So 2x squared times ax will give me 2ax cubed, and then 2x squared times b will give me 2bx squared. Now 3x times ax will give me 3ax squared. 3x times b will give me 3bx. And finally, let me use a green pen now. Negative 2 times ax will give me negative 2ax. And also negative 2 times b will give me negative 2b. So let us just simplify this and try to group the terms with the common coefficients together. So we have 2ax cubed plus, over here we have 2b, let us factorize, 2b plus 3ax squared. Okay, so I'm factorizing these two terms over here. And over here we have 3b minus 2ax, and finally we have a negative 2b at the end. Now we can compare coefficients. So comparing coefficients of, let's say, let us pick a coefficient to compare. So let's say we compare the coefficients of x cubed, for example. Now on the left, we have 4x cubed, and on the right, we have 2a x cubed. So we can say that 4 is equals to 2a, and therefore a is equals to 2. Now let us compare the coefficients of x squared, for example. So let's compare the coefficient of x squared, and we can see that on the left we have 0x squared. Okay, 0x squared. Okay, and on the right we have 2b plus 3a. Okay, so 0 is equals to 2b plus 3a, and a we found to be 2, and therefore simplifying this, we will have b is equals to just -3. And finally, let us compare the coefficients of x. So let me use a different color. So the coefficient of x on the left hand side is c, and on the right hand side we have 3b minus 2a. Okay, and so comparing the coefficients of x, we have c equals to 3b, and b we found is -3, minus 2a, and a we found is 2. Okay, and simplifying this, we will just get -13. So you see that we arrive at the same few answers, which is a equals to 2, b equals to -13, and b equals to -3, and c equals to -13. Okay, and there we have it. This is the comparing coefficients method of solving identities. Okay, so I hope you have enjoyed this video. And just to summarize, polynomials are identical when every value of x simplifies each polynomial to the same value. We can find the unknowns in an identity of x, okay, in x, by either of these methods which we have just explored, which is the substitution method or the equating coefficients method. So let me just highlight this for you. This is pretty important. You might want to take this down: substitution method or the equating coefficients method. So before we end off, just leave you with some practice questions over here. Feel free to pause the video here to take them down. And finally, thank you for watching this video. For more videos, please log on to pencilcollege.com. I'll see ya.